questions about equilibrium? How does everybody feel about equilibrium? Wonderful! Alright, well, I have 5 equilibrium problems. You should have enough knowledge now to do all 5 of these. And they should be fairly stereotypical of what we want to be able to do. I got my whiteout ready. I'm going to try and use pen. It shows up so much better than pencil. The equilibrium constant for the reaction below is 5.4 times 10 to the 13th. At some temperature. Does that favor reactants or products?
Reactant. Products.
Products. Yeah, huge number. Got to be more of this at equilibrium than anything else. So it says, what is the value at K at this temperature for this reaction? Looks similar, but different. So the way I'm going to approach this, I'm going to look up here and say, look, here is a product. Down here it's a reactant. So I'm going to just carefully rewrite the top equation in reverse order. So far, so good. Now, what would be the equilibrium constant for this equation? Since I've flipped it around. Yeah, the inverse, or the reciprocal. 5.4 times 10 to the 13th. Now it looks like I'm almost there. I got my N2 where it should be, my NO. Well, looks like I did that a little backwards, but that's alright. So now, what happened? This 2 is now gone. That 2 is gone, and there's a half there. So that means that I want to times this equation by a half. So that's going to give me NO2 in equilibrium with a half of O2 plus an NO. Alright, so now I have this thing. So if I multiply an equation by a number, what do I do to the equilibrium constant? Exponent. Yeah, I got to raise it. So now my K for this is going to be this thing, raised to the 1/2. What's another way of saying raised to the 1/2? Yeah, it's the square root. So on my calculator, there's probably a couple different ways I can proceed. It kind of looks like what I got written here, and we see that this equals 1.3608 yada yada times 10 to the -7th. Which one does that look like? 2 digits. That is going to be that one there. So a good review with manipulating equilibrium constants. I have this equilibrium constant here, 5.4 times 10 to the -13th. Write this equation the other way around. It's the reciprocal. And that kind of makes sense when we think about our equilibrium constant being a quotient of products over reactants, of course raised to the coefficients. So write this thing the other way around. Got the reciprocal relationship. If we multiply by a number, we got to raise the equilibrium constant to that number. Any questions on this one? At 400 Kelvin, the equilibrium constant for the reaction of Br2 plus Cl2 going to 2 BrCl, all in the gas, is 7. A closed vessel at 400 Kelvin is charged with 1 atmosphere of Br2, 1 atmosphere of Cl2, and 2 moles of BrCl. Use Q to determine which statement below is true. I mean, there must be. So what is Q? It's just looks exactly like the equilibrium expression. Right, when they're not at equilibrium. So I'm going to have the pressure of BrCl, and that's squared, divided by the pressure of Br2, multiplied the pressure of Cl2, like so. Alright, and this equals K when it's at equilibrium, so it's all set up the same way. Now I gotta read through all this and figure out that my pressure up top is 2 atmosphere. And since equilibrium constants are kind of unitless, and I'm lazy and in a hurry, I'm not going to worry about atmospheres. So I've plugged in the pressures there. It says it's charged with 1 atmosphere of Br2. That's that. 1 atmosphere of Cl2. And 2 atmospheres of BrCl. So I got to pull out my calculator, right? To go 2 squared is 4 divided by 1 divided by 1, or the product of 1 divided by 1, which is 1, divided into 4 is 4. There it is. So we might say 4 is less than 7. We got Q less than K. So our K sub P is equal to 7. Plug in these things and we see that Q is less. So the other day we learned that that means that this reaction moves this direction. Products, we need more products. And then if we look at this has got to be false because we're going to burn some of these up moving in that direction. These are going to go down. That's going to go up. This would be true if the reaction went the other direction. That's false. At equilibrium, the total pressure will be less than the initial total pressure. We can tell that that's a false statement because I have 2 molecules of gas on this side, 2 molecules on that side. So as long as they change, the total pressure is going to be the same. We could even calculate the total pressure. The total pressure is 4 atmospheres. So I have 1 atmosphere of that gas, 1 atmosphere of that gas, and 1 atmosphere, and it'd be this law of total pressures. We're getting distracted, people. That's alright. So this is false. Now if it moves this way, I said it wants to do that and it's going to consume reactants and make more product. So this statement here is the only one that's true. Let's read E just to see what's going on. The reaction will go to completion since there are equal amounts. Go to completion. We just figured out in this chapter that equilibrium doesn't necessarily work that way. So what do you think about this question? Using Q. Q equals 7, we would be at equilibrium. Q is greater than K, the thing would back up. Does everybody see how we came up with D being the only true statement? I only see like one nod. Alright, we're going to move on. Consider the chemical reaction. Carbon monoxide and 2 hydrogen gas molecules come together and form, looks like a molecule of methanol, CH3OH. At equilibrium, in a particular experiment, the concentration of CO and H2 were 0.15 and 0.36 respectively. What is the equilibrium concentration of CH3OH? The value of the equilibrium constant for this thing is 14.5 at this temperature. So no ice table yet. Let's just write down, and since they're giving me these in molar concentration, I'm not going to go K sub P, I'm probably just going to go EQ like they got. Sometimes I say C for concentration. Let's just write this expression. There's my expression, and now I'm gonna just plug things into that. Say what we have is some unknown, because it says what is the equilibrium concentration of methanol, and I got methanol right up top there. And then we got numbers for these other things. Sometimes when it says respectively, I gotta make sure I get everything in the right spot. And we know what this equals, 14.5. We can just multiply all these together. If I did my algebra, I'm gonna multiply both sides by 0.15 times 0.36 squared times the equilibrium constant. There it all is. Times both sides of the equal sign by this to get this to cancel out and bring it up there. If you don't remember the algebra, that's the algebra. So then I can do something like 14.5 times 0.15 times 0.36 squared. Hit the enter key, and I wouldn't normally mess with the scientific notation, but that means this is the answer. Any questions on this question? Got an equation, got a constant, we have some concentrations. They ask us what's this got to be? It's got to be some exact number to equal this, and so we were just able to solve for that. At equilibrium at 25 degrees C, if we weigh out enough of this stuff, put it like in a liter to make a 1/10 mole solution, we find the following concentration. And it says, what is the equilibrium constant? Just plug in all the numbers, right? Right, so here we're told it's at equilibrium. All we have to do is write the expression, plug in all the values. All right, while you're thinking about that, I'm going to write down this equation. So the reason why I write down that equation is I want to use each one of the species as a heading. A heading in a table, right? What type of table?
Ice.
An ice table. Absolutely. Initial, change, and equilibrium. So it says here, this thing, we plug in 0.123 atmospheres of this gas. I'm in too much of a hurry. I'm not going to worry about any units. Old chemistry teachers are spinning in their grave. So those must be 0 at the beginning, right? And if we plug things into Q, 0 divided by any number is what? 0. Q has got to be less than K. The thing's got to move to the right. If things move to the right, some of this disappears. Some PCl3 is going to form. Likewise, some Cl2 is going to form. We don't know how much, so what do we call it? Act by the pressure of phosphorus pentachloride. Bless you. So there's our equilibrium expression. Now we want to plug in the bottom of our ice table into the equilibrium expression. So I'm going to distribute this number through the parentheses. I'm going to have x squared equal to. So now I might have to pull out my calculator and go 0.012 times 0.12 and come up with 0.0014883 minus, and now just 0.12x.
Shouldn't it be 1.0?
Right there, thank you. I knew I brought this in for a reason. I said I'm going to make a mistake. Thanks, Caden. All right, now, do you have any math teachers that get way excited? I know one has a reputation. My students say he's a spaz. At this point, your math teacher should be getting all excited. I'm gonna add this term to the other side. I'm gonna do it correctly. Now I'm gonna subtract that from the other side. When I do that, that gets set equal to 0, right? Now, why do math teachers get excited at this point? Absolutely. Minus b plus or minus square root of b squared minus 4ac divided by 2a. So how many of you have a Texas Instrument like this one? Calculators have destroyed my mind, but on this calculator, if I go to this thing called apps, and it's way down, it's so far down, I'm going to use this alpha key and hit P. So it begins with P, and right here, this thing, I call it polysmelt, because that's just the way I read it, but it's polynomial simultaneous equation solver is what it is. Put that in there. See, poly root finder, there's the simul. It actually does all these things. We want the first option. And we want a second order polynomial. And I did this before I came to class. So here I enter a 1, because that's my coefficient in front of the A term. And then, I'm trying to mess this up. And then I put in 0.0121 for my B term. And then for my C term, negative 0.01488. And I hit solve. And notice there's 2 solutions, just because that's the nature of the quadratic. And then we get to this point, and we might look at our ice table and say, here's x. Does a negative x make any sense?
No.
Now there's other times when you have x plus something minus something, and then you might have to consider that other solution to the quadratic. But looking at this, that means we got option D. And of course, if we wonder, is this right? How can we check it? We could plug this back in. All right, I think there's just enough time for you to take your quiz.